Welcome to part 2 of our bus build series. If you haven't watched part 1, you'll want to check that video out first and then come back to this one because we have a lot of overlapping information. The purpose of this video is to equip you with as much information as we can, giving you the tips and tricks that we learned along the way, and give you information for you to make an amazing build.
We're not saying that we know everything or that we did everything the perfect best way. We definitely did not. This is our learning experience bus, and yeah, we learned a lot along the way. Come along with us on this video as we share with you our design intent, my actual design, our build footage, and then the mistakes that we made and ways that we could improve it in a future build. So the first design consideration that we had was security. We wanted the doors on the underbay to be secure at all times, and we didn't want to have to worry about them. And to accomplish that, we used locking door latches, and the hinges we used cannot be taken off or unbolted or pulled the pin out while you have the door secured. And we also wanted the doors to be thick enough and heavy duty enough that you can't really pry them open or break into them in any way. We also wanted the underbay doors to be serviceable in the future. So to do that, we had hinges that we can actually grease so that if they start squeaking or start becoming hard to open, we can just pump a few pumps of grease into it and they're like new again. We also used door latches that we can unbolt from the inside and swap them out if we break off a handle or something happens in the future where we need to fix it. And also the doors themselves can come off. If you open the door up and lift up, the doors will clear the actual underbay and come right off if you need to work on them.
Another consideration that we had was the size of the doors. We wanted to make sure all of the doors were standardized to be the same dimensions from door to door. We also wanted to make sure that we maximized the height to fit like large storage totes or like as big as objects as we really could. But on the same line, we wanted to make sure that our width wasn't too wide so that we could still open the doors even if we were parked in a parking lot.
So the underbay doors would not be very useful if they weren't watertight. We wanted to have a nice sealed, airtight and watertight underbay. So to do that, we have a bulb type weather stripping that we ended up having to wrap around the inside of the doors, and they seal them very well. We don't have any water leaks. And along with the weather stripping, we also have an overlapping inner frame to the door that doesn't allow water to get inside. It traps it and directs it around to the bottom of the door and then out through the bottom of the underbay wall.
Another consideration that we had was the orientation of the latches. So we wanted to make sure that if we did a side latch, that it wasn't going to be a suicide door, meaning that it would be on the back side, which is why we put them on the front. Another option that we see a lot of Skoolie conversions go with is a top hinge, so it can flip up to become a table, but we didn't want that because then we wouldn't be able to see inside of the actual doors as easily without having to crouch down.
Yeah, and with the suicide doors, what we're really talking about is if the wind catches the door, if it's left unlocked or unlatched, it won't flip open and back and slam into the back of the bus. It will just stay pushed shut with the air pressure of the air flowing over it. So because the rest of the underbay is insulated, we also wanted the doors to also be insulated. And to do that, we ended up welding some studs onto the back side of the door. And then we were able to slide insulation over top of that. And we don't have it finished yet, but we have the ability to put covering like a plastic on the inside to protect the insulation from damage. So here we are back in SolidWorks. I've updated the model of the bus to include the underbay doors. So the underbay doors, there are 4 of them on the passenger side and 3 on the driver's. So on the driver's side, I spaced the doors out in an odd pattern, and that was because I have utilities in this front section here that I need access to as much as possible. And at the back, I just have my gray and black tanks. So I didn't really need a ton of access, just where I need to hook up the dump hoses. So that's why that side is spaced the way it is. And on the passenger side, it's just storage on this side, so I spaced them evenly, and that allows for the most convenient access on this side of the bus. If we zoom in on one of these doors here, you'll see the basic construction. It is an angle iron frame with an inset smooth door face. And the way we built these is we cut out an oversized hole with a plasma cutter in the walls of the bus. We then trimmed down the scrap piece so it fit within the frame, and then welded it into the frame. And that basically uses the scrap sheet metal piece from the bus as the door, the face of the door. And that cut down on scrap. I only had little slivers just for clearancing for inside the frame. So it worked out really well and was pretty efficient with our resources. At the front, or towards the leading edge of the door, we'll call it, we welded these bullet hinges. So one part of the hinge is welded to the frame of the door, and one part's welded to the inner frame / wall of the bus. We can get away with welding it to the wall because we used a pretty thick gauge sheet metal. If we open the door up here, you'll see the inner frame, which is in black. That frame is what holds our weather stripping in the right location to seal the door, and it directs water around and down both sides of the door frame. Basically like little gutters. We went with this framing method because it's fairly foolproof and it creates a great seal on the doors. On the back side of the door here, you'll see we have these orange studs. They're actually just bolts that were welded to the inside face of the door. And those allow us to hold our insulation, what's shown in pink. And then it'll eventually, if I ever get to it, we will put a piece of like 1/2 inch, or probably more like 1/4 to 1/8 inch plastic or 1/4 inch plywood on the inside of the doors to protect the foam and make a more finished looking door. Okay, so now we're going to cut the bus in half so I can show you a cross section of the door framing. So here you'll see just a cross section through the bus here, and you can tell now how our doors are actually framed. So this black portion is the inner door frame, and the orange portion is the actual door itself. So you'll have to imagine the bulb weather stripping filling this space here, which is attached to this flange on the inner frame. And that seals really well in here and directs any water back into this channel and around the door and down through the bottom. So it's the same all the way around. Here on the bottom, I didn't quite model it perfectly. There's actually a C-channel piece of metal here. So any water that comes into this area just drains through weep holes in the bottom of the C-channel. This inner frame also serves to provide support for the whole door. Because the weather stripping is so tight, it seals up against the inside of the bottom, or the inside of the door frame here, and creates a nice strong support all the way around the door so that we're not bouncing down the road and putting all our load on these hinges. It's also supported on this side because the latches that we used do not actually provide any weight bearing. They're rollers that catch the inside of the frame. So they're not modeled, but they catch the back side of this frame and just hold the door from coming out. So the only parts that we bought for this, besides just sheet metal, are the bullet hinges, the door latches, and the weather stripping. Check the description of the video for links to similar or identical products to what we used. You can use those as a good stepping off point in trying to find what you need for your particular application. So now that we've gone through the design of the underbay doors, let's go and build them. Our doors, we made a frame, 1.25 inch bent angle iron, and welded our bullet hinges on here. We'll have a door like a service truck style door latch that will go right over there. This one's just tacked in, and we got it squared, made sure it all fit, and I'll pull this one apart and weld it up good. I did prime the whole thing, all the actual framing members. Primed everything before we did the side skirts. That way I have primed metal. I primed both the actual framing and the backside of our skirt panels. That way it prevents some rust from happening, and try to control it. This is one that I have halfway done, so I have all my welds in here. I just have to grind them down and smooth them out. So I'm just using that weld on the very lip of the frame there. That should be enough to hold it along the inside there. I do have to do a little bit of welding on the back side, but I have to make sure I don't hit any of the floor panels when we go to put it up, so I have to measure it out and tack it strategically so I don't run into clearance issues later on. But yeah, this is one that's halfway done, and this one is completed, so it is sitting in here how it's gonna be. We have to put our weather stripping. The weather stripping will go on this inner rail, so the door will close tight against that and seal. And any rain that gets in from the top here has to go around and down the side of the channel, and then I'll have weep holes drilled in the bottom side of the channel to let any water out. So it's a fairly simple method of sealing a door, but it should be effective. But yeah, this one I welded up the corners nice. Actually ground out the tacks that we had on the front side. It was just easier to tack it from the front and then grind them down. And then yeah, I welded it solid from the other side for the door, and then just ground off my welds here on the outside of the doorway. These hinges are super nice. You just weld them on, and they're greasable, serviceable to an extent. So yeah, well worth it versus like a piano hinge style. So here are the welds that I put on the inside. So it's just tacked in. This is a 1/4 inch plate, so it is stout and won't go anywhere. It's a very heavy door. So here I have all those tacks in place and ready to just letting it cool, and I'll flip it over, and I have to weld the hinges yet on this panel, and this one will be good to go. But yeah, we still have one whole panel to go, so we're not quite done yet, but it'd be nice to get these done and get them hung back up on the bus, and that will allow us to really start putting the framing of the underbay up permanently after I get it insulated. So it's exciting to see progress. But these doors are way more work than I had initially planned. I'd actually hoped to have a local colony do the doors for me, but they were I came in with a quote of about $200 a door, so it wasn't quite feasible. I'll rather spend a week or two doing the doors than spend that. So yeah, it's coming along really nice. I will set up a time lapse and let you guys watch me work. thing you may have noticed is that I got the doors put on. Yeah, the doors aren't done. We still have to get all of our gaps standardized and make sure all the doors function nice. We also have to cut the handles in. These doors are in too. I think they look pretty sharp. It'd be really nice to get them all gapped correctly and put the latches in, but yeah, project for another day. So here we are at one of our underbay doors, and they're all the same, so I'm just going to go over one of them and then we'll apply to all of them. So on the passenger side of the bus, the hinges are towards the front there. Those are those greasable bullet hinges, and they're just welded on to the actual door frame and then to the metal of the side wall of the bus. And that we could do that because this is 1/8 inch sheet metal, and everything's been holding up great. The doors themselves have a nice service handle door lock on them, and we had the T-handle style that twists and has a locking kind of a roller system on it. And yeah, that exposes the inside of the underbay. We have a inner frame for the doors that we have our bulb type weather stripping on. And then on the inside of the door here, we just have our insulation mounted up. It's one of those things we haven't gotten to. We wanted to put some paneling on the inside of this door and then just put some nuts and some washers and nuts on it to hold it on, but just haven't gotten to it yet. So as you can see, we tried to maximize the height of our underbay doors. They're actually just a little bit too low, that they are lower than the flooring, but it's not a bad thing. The top dimension of the door is constrained by the ribs of the floor of the bus. We can't go any higher than what we have now with the framing. So we maximize the height, and the width is just wide enough that if you're in a parking spot in a truck stop or something like that, you can still get the doors open at least most of the way. And I wanted to show you the security of the door. So with these hinges, they have to be lifted up in order to take the doors off. So you have to have the door completely open in order for the actual door itself to clear the wall of the bus to be able to lift them up. So when you buy service truck door handles, you can get them as a set or so that they all have the same key. So all of our door latches share one key. Makes it super convenient so that we don't have to have a giant key ring just to get into the underbay. So with the door latches that we got, they rotate on the inside to close, and they grab the frame of the underbay wall. But in this instance, we have some framing for the tank supports that would get in the way of it rotating from the bottom up like it had to on this side of the bus. So you can actually modify them so that they can rotate either way to latch. So we have one handle that rotates the wrong way, but at least we can latch all of our doors. So the first mistake we made was not accounting for the complete thickness of the floor when we made the openings for the doors. And because of that, our floor is actually higher than the door frame. It's not a huge deal, but it's a little inconvenient. But yeah, like I said, not a huge deal. It kind of actually protects your weather stripping from when you pull totes or things out, it doesn't tear the weather stripping off. So the next problem that we had was when we were welding up our bullet hinges, you're kind of just holding them there and approximating as best you can the right location for them. And we didn't use a jig or anything, we just held them. And because of that, some of the hinges don't clear, they have clearance issues, so they scrape some of the paint, and they were a big deal. I had to grind and shape some of the hinges because they would either bind or scrape all the paint off. What I should have done differently was build a jig and make them so every door was the same, and that you could actually swap the doors between each other, because right now each door is individually fitted for the spot it's at. So another smaller mistake that I made, but it was kind of a pain to remedy, was I didn't grease the hinges right away. After we assembled the doors for the last time after painting, I thought it was nice that there wasn't any grease showing or anything like that, but it ended up being a problem where it took quite a while to get all the hinges to take grease again. We have them all greased now, but it took a little over a year of fiddling with different grease gun fittings and different grease guns to get enough pressure to actually clear some of these hinges. So another one of our big mistakes we did with these doors was we didn't use a jig when we cut them or built them. We kind of built them all just using, like, measuring each one individually. We didn't like actually lay out a jig so that they're perfectly symmetrical and the same. So we have clearance issues, or they're not the same gaps, like top to bottom. They all work, but the lines could be a lot tighter and neater overall. I also didn't do a great job finishing the cuts we did on the door, especially the frame itself. It doesn't look quite as nice as it should, and just not as polished as a finished product as I would have liked. I wish I'd taken more time in like putting Bondo and welding and grinding and smoothing the actual openings on the walls. So when we built the doors, we ended up just cutting with a plasma cutter out the opening of the door, and then we trimmed the scrap piece out and then welded it in to the frame to make this actual panel here. And it kind of made things more difficult than it needed to be. If we had had one solid smooth door, you wouldn't have had to do seam sealer around the perimeter of this frame, and you would have had a nicer, neater look overall. If I were to do it again, I'd probably plasma cut a very careful line all the way around and then mount my frame on the back side of my panel so you get a nice, just smooth wall to the bus with just one little gap where the door actually opens and closes. So ways that I can improve on the door design, the first one would be to maybe try a different latching style. This style needs clearance, quite a bit of clearance, enough to fit this whole roller assembly on the back side of the door frame. And this door in particular has a tote that's about the same height. So I have to make sure that tote is pushed back in order to actually latch the door. There are some that have a stud in the actual frame here, but that also has a problem that you're going to catch that when you're pulling stuff in and out. So I would probably play around and see if there's a better latch design that would work better in this situation, I guess. Another nice thing to have added to the doors that we didn't would be a gas strut. So the door will stay open, it'll open up and just hold at a right angle. I don't know if it would have been super necessary or we would have liked it in the end. It could have been a chain too, just to have something to keep the door from swinging all the way open and back into the bus, like so. Another improvement that I might have experimented with or thought about a little bit more would be flip down doors, where you have a nice solid door that you can actually crawl on to get into the underbay. While I was working on it, would have been nice because then you would have a spot to slide out and then you can get up from it. You don't have to do a contortionist stack to get in and out of the underbay. And then it would have been a little bit easier for loading totes and stuff. You can just set stuff on the door and then slide it in. The one issue that might arise with a door like that is that you have to build it way heavier, and then you have to have plywood or something else on the inside face of the door in order so it doesn't get dinged up or damaged. The next thing I would have probably wanted to improve on was to find a different insulation for the doors themselves and to very carefully measure it so that it covers every square inch of the door that we can. There's some clearance issues with the door swinging where you need to clearance things enough that you don't have it bind up on the inner frame of the door, but that would be something we could improve on in the future. Another cool thing that I wish I had added or would add in the future would be a momentary pressure switch on the doors so that when you open them up, a light comes on above the doorway. So when you're trying to get something out in the dark or need to work in there, it's super easy. Just open up the door and you have light. You don't have to have a flashlight. So for the last improvement that I would do to these doors would be kind of similar to the last one. I'd have a momentary switch on it and then have an alarm system so that if you have the system armed and someone opens the door or breaks in, an alarm goes off, and it's kind of just an extra security feature. So that brings us to the end of this build video. If you have any questions about the build or want further information, feel free to leave a comment down below and I'll do my best to answer them. I'm by no means an expert on these bus builds, so use what I've shown you guys as a good stepping off point, as a reference, but don't follow it word for word because there's probably much better ways to do things, and yeah, we're always getting better. If you like this video, you'll definitely want to subscribe to catch the rest of the build series. We're just getting started. Thank you guys all for watching, and I'll catch you on the next video.